Now from BPT, we have its converse. Converse means the opposite. BPT said if you draw a line that is parallel to the third side, then it will divide the sides of the triangle in proportion, right?
Yes.
Converse of BPT is if the sides are proportional, then this line must be parallel to this. Okay, so if a line, yeah.
Yes, sir.
Okay. So, I mean, BPT said that if the sides are, if you draw a third side that is parallel to this side, so the sides will be divided proportionally, the opposite sides, right? So, AD upon DB is equal to AE upon EC. This theorem is about the converse of BPT. So, it is already given that these two sides are proportional. So, AD upon DB is equal to AE upon EC, right? Then you have to prove DE is parallel to BC. So this is the opposite, right, of BPT.
Yes. Yes.
So you may be given any of these, so you have to apply either BPT or its converse to get the answer. So here what you do is, first of all assume that, yeah,
It is given that the sides are proportional, so it means that the triangles are similar, right?
but for now you don't know.
Okay.
So you are only given AD upon DB. So see, when you learn about similarity at a later point, then you can use that to prove. For now what you have in hand is the BPT only, right?
Okay. Yeah.
So again, you will write the general terms. Uh, Given what is given, AD upon DB is equal to AE upon EC. Right? What you need to prove? You need to prove DE is parallel to BC. Right?
Yes.
So to prove this, assume that DE is not parallel to BC. So there is a point E dash that is parallel to. So if E is not parallel to BC, DE, so there must be a line, say DE dash, which is parallel to BC. So assume DE dash is parallel to BC. Okay. So if this is parallel to BC, yeah, you have any question?
No, sir.
Okay. So then you can write if DE dash is parallel to BC, so you can apply BPT which you have already studied, or theorem 6.1, right? So you can write AD upon DB is equal to AE dash upon E dash C, right? So this is from BPT,
Yeah.
right?
Yes.
And it is also given AD upon DB is equal to AE upon EC. It is already given,
Yes.
right? So from these two equations, you can say AE dash upon E dash C is equal to AE upon EC.
Yeah.
So from this, can you say E and E dash is the same?
Yes.
No, you cannot. What is this saying? It is just saying that the ratio of these 2 points is equal to ratio of these 2 points.
Sir, so it means that the points are like coinciding on the same point,
No,
right?
but
So,
if their ratio is same, does it mean they are coinciding? They may coincide or they may not coincide as well.
okay.
Right? Say if E dash is somewhere around here, or E dash can be somewhere around here. Right? So it is just meaning that ratio is same. So for now you cannot comment whether they are same or not. Okay? So I mean, in order to prove what you do, you can just add a point. So either you should have same numerator or same denominator. At least one should be same, then only you can prove. Right? So you notice that if you add E dash C to this will become AC. Right? And if you add EC to this, it will become AC. So that the numerator will become same.
Okay. Yeah.
Right? So you can then add 1. Right? So although from here it may look to us that E and E dash are coinciding, but we have to prove that mathematically. Okay? So you can write AE dash plus E dash C upon E dash C is equal to AE plus EC upon EC. Right?
Yeah.
So this becomes AC. So AC upon E dash C is equal to AC upon EC.
Yes.
Right? Now you can cancel this AC and AC. So you'll get EC is equal to E dash C.
Okay.
What does this mean?
It means E and E dash are coinciding.
Yeah, so that initial assumption was that,
It was wrong.
yeah, it was not wrong. So say we assume that DE dash is parallel to BC. So this becomes, since E and E dash are the same, we can write DE is parallel to BC.
Okay.
Okay, is this clear?
Yeah.
Fine. So, I mean, exercise 6.2, you'll only have to deal with these two theorems. One is BPT, the other is the converse of BPT. So, for example, if a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC. So, if a line intersects side AB and EC, so you have a line D which intersects AB and AC, right, at D. So it intersects AB at D and AC at E respectively, right? And it is also parallel to BC. So D is parallel to BC, right? Prove
So it
that.
is
Yeah,
BPT, right?
sorry.
It's BPT, right?
Yeah, you have to apply BPT, right? So you have to prove that. So now look at the proof. It is not saying prove that AD upon AB. It is not saying prove that AD upon DB is equal to AE upon EC. You have to prove that AD upon AB is equal to AE upon EC.
Okay.
Right.
Yes.
So you have to, although you have to use BPT, but then you have to make certain adjustments. We discussed about that adjustment, right?
Yes.
So again, whenever you are writing answers, you should write what is given. So given D is a line segment that intersects AD at AB at D and AC at E. So this is the first thing. Although this does not give anything valuable. Second thing is D is parallel to BC, which is important.
Yeah.
So to prove, what do you need to prove? AD upon AB is equal to AE upon EC, right?
Yes, sir.
How can you prove this?
So we just apply the BPT, and in the proving part, instead of AD upon DB, we can take the AB as whole, because if we know that AD upon DB is equal to A upon EC, like the BPT, so
Yeah.
we can tell that AD upon AB will also be the same because AD is common in that.
Yeah, so you have to prove that mathematically.
Yes,
Right, say you'll write, since DE is parallel to BC, therefore from BPT we can write AD upon DB is
so
equal to AE upon EC.
we don't have to prove the BPT.
Yeah, you already know because that is a theorem,
Okay,
right? So you already proved BPT earlier, so you don't have to prove it again in every question. Until and unless you are explicitly asked to prove BPT, you don't need to.
okay,
Okay. So you can say AD upon DB is equal to AE upon EC, right?
yes.
Now what can you do?
So AD upon DB is equal to A upon AC,
Yeah,
right? So it means that the whole side should also be equal, like AB should be equal to like AC,
AB should be equal to AC,
like not equal to
proportional.
but proportional. Yes.
Yeah, but how can you say that? I mean, you have to justify what you're saying.
So we can add AD plus DB.
You can add AD plus DB. Yeah, you can add AD plus DB. Yeah. So by adding one, you can achieve this.
Yes.
But see, say let us just add one to the left hand side. AD upon DB plus one, right? So you'll get AD plus DB upon DB, right? So AD plus DB is AB.
Yeah.
AB, so you got one of this, but on the other hand, you are getting DB, which you don't need. Ideally, you should have got AD upon AB. So you got AB, but you are getting DB in the denominator.
Okay. Yes.
So what went wrong?
We had to take the upper triangle, the smaller triangle.
Yeah. So instead of doing that, you had to first flip this
Yes.
so that AD becomes the denominator. If AD is the denominator, AD will remain unchanged and the numerator from DB will vanish to AB.
Yes.
Right, so you can write DB upon AD is equal to EC upon AE, right?
Yes.
Then if you add 1 to both sides, so you'll get DB plus AD upon AD is equal to EC plus AE upon AE,
Yeah.
right? Now you get what is AB, AD plus DB is AB,
Yes.
right? So AD, AD is here plus DB. So AD plus DB you got as AB and AE plus EC you'll get as AC, right?
Yeah. So we have to first write the BPT, then like inverse them and add one on both sides.
Yeah. So this step is very important, this flipping the terms,
Yes.
right? So now you just again you should flip the term again to prove what they are asking exactly,
Yes.
right? Is this proof clear?
Yes, sir.
Then you have ABCD is a trapezium with AB parallel to DC, right? Then you have E and F are points on non-parallel sides AD and BC, right? Respectively, such that EF is parallel to AB. EF is parallel to AB. Yeah.
Sir, AB is parallel to DC, right?
Yeah.
So why is it saying non-parallel sides AD? Okay.
This and this is non-parallel.
Yes.
Right. So it is saying E and F. So E and F are points on non-parallel sides.
Yes.
Right. Such that this EF is parallel to AB. So which means all three of them are parallel to each other.
Yes.
Show that AE upon ED is equal to BF upon FC. This is already known fact from BPT. But to show that you have to draw triangles. So you either join this. Yeah, go ahead.
I thought we could just connect point A and B on an imaginary point above them, like making a triangle.
This one.
Yeah. So then we can apply BPT directly, right?
So say this is O,
Yes.
right? So when you apply BPT, you can say OA upon AD is equal to OB upon BC.
Yeah.
Then you can write OE upon ED is equal to OF upon FC.
So then we know that OE upon AD equals OF upon FC.
Yeah.
So if so, we also know that OA should be equal to AB, right?
It is not mandatory.
Or we can prove, like we can write it in the construction because we are making it.
No, but how can you ensure that these are equal? Say,
Because
for example, if the inclination of this would have been like this,
yes,
right? Because they are non-parallel, so angle can be anything. So can you say these are equal, this and this? No, right?
but the non-parallel sides of our trapezium are equal, right?
This and this,
Yes.
it is not always true.
Okay.
Right, so that is a different type of trapezium. I believe it is a regular trapezium.
Yeah.
Okay, so I mean, this won't work. It can work, but it will make things very complicated. Because what do you need? You need AE, ED, and BFFC. If you add a extend the triangle like this, you are adding one more thing, OA, right?
Yeah.
Which can make things complicated. Why I am adding a triangle like this? So see, you can either add a triangle like this or like this. I've chosen like this. Now if you just make this O, right?
Okay.
So then you get one triangle ADC, right? And since EF is parallel to DC, you can say EO is parallel to DC as well.
Yes.
So apply BPT here, so you'll get AE upon ED is equal to AO upon OC, right?
Yeah.
Then again in the second triangle you can write, what can you write?
And triangle BDC, right?
BDC. Do you need BDC or will your work be done using this triangle only? Because you need to find this common diagonal, right?
Yes.
You need to use this common diagonal, and diagonal will already divide into two equal halves. I mean, two triangles. So what is the need to draw another triangle?
Yes.
right? So
So
yeah, go ahead.
in triangle BAC,
Yeah, BAC.
FO is parallel to BA.
Yeah. So
So we can tell that CF upon FB equals to CO upon OA.
CO upon OA,
Yes.
right? So now you can see this is AO upon OC and this is CO upon OA. So if you flip this, they'll become equal.
Yes.
So FB upon CF is equals to OA upon CO or OC, right? So from this and this, you can say AE upon ED is equal to FB upon CF,
Yes.
right? So this is what you had to prove. AE upon ED is equal to FB upon CF.
Yes.
Any question?
No, sir.
You'll get the same answer if you join these two. Maybe you can try doing that later.
Okay.
In figure 6.16, PS upon SQ is equal to PT upon TR and angle PST is equal to PRQ. Okay, prove that PQR is an isosceles triangle.
So we just have to prove either angle S is equal to angle T or angle Q is equal to angle R.
Yeah. So you have to prove PQR is an isosceles triangle. So you can prove Q and R are equal.
So we can say S and Q will be equal because they are corresponding.
Yeah, first of all, why can you say that? Because it is not given ST and QR are parallel.
Okay, yeah.
So is there anything you can use to prove that they are parallel?
The sides,
Yeah,
like
so,
if
so see, the question says PS upon SQ. That is why it is very important to write these down. So you can write given. What is given? PS upon SQ is equal to PT upon TR, right? What does this information tell you?
so they the triangles are similar.
For now, you don't know.
Yeah. So we can say SG is parallel to Q, BPT, right?
Yeah, converse of BPT,
Yeah.
right? So this, now you know ST is parallel to QR, right?
Sir, is there any name for converse of BPT?
No, you can just write converse of basic proportionality theorem. You
Okay.
don't have to specify theorem number 6.1, 6.2 because 6 is chapter number. It is not any order of theorem or formula that you have to specify. You can just write from basic proportionality theorem. Okay, and for this you can write from converse of basic proportionality theorem.
Okay.
Okay, so here it is saying theorem 6.2 because it is using it to refer to the theorem, but you can write converse of BPT, right? So you now know ST and QR are parallel. Once you know these two are
Yes.
parallel, so this and this becomes corresponding angles. So because this and this is a parallel line and this is the transversal, so S and Q are corresponding angles, right?
Yeah.
So angle S is equal to angle Q, but it is given that angle S is also equal to angle R, right?
Yeah. So
So
angle
yeah, go ahead.
Q should be equal to angle R.
Yeah, so from both these equations you can say angle Q is equal to angle R. When two sides of a triangle are equal, I mean two angles of a triangle are equal, just the triangle is an isosceles one.
Yes.
Any question?
No, sir.
Or say when two angles are equal, the opposite sides are also equal. So that is why it is an isosceles triangle. Okay. So in figure 6.17, 1 and 2, D is parallel to BC. D is parallel to BC. Find EC in 1 and AD in 2. So this is unknown and this is unknown. Okay, can you tell me the value for both?
Sir, EC should be 2 centimeters.
EC should be 2. Yeah, 1.5 upon 3, so which is half. So 1 upon 2 should also be half. Yeah,
Yes.
this is correct.
And AD should be 2.4.
82.4. Yeah. So the ratio is 1 upon 3 for both the cases, right?
Yes.
Okay, very good. So E and F are points on sides PQ and PR respectively of triangle PQR. So see, when you are given questions like these wherein no diagram is available, you have to build diagrams. So first of all, go through the triangle or quadrilateral, whatever is given. See, it is given triangle PQR, right? So you first draw this triangle.
Okay.
This is P, this is Q, and this is R. Okay. E and F are points on sides PQ and PR respectively, which means E is point on side PQ. So take a point PQ, so put aside E, right? And then
Yes.
another side F. F can be anywhere, so you need one more information. It is given EF and QR are parallel. So it should be
Okay.
along the same line, right?
Yes.
So this is EF. So EF is parallel to QR, right? For each of the following cases, state whether EF is parallel to QR. Okay, so it is not given, you have to prove or find whether EF is parallel to QR based on the measurements.
Yeah.
Okay, so first question says P is 3.9, EQ is 3, PF is 3.6, and FR is 2.4.
Yeah, they are not parallel
Why?
because they are not proportional.
Yeah, so this you'll get
So,
1.3,
yeah.
right? Here you'll get 2 and then 1.8, so 0.9. Right, not exactly 0.9. So 36 upon 24. What is the value? So 12 3s are 36 to
3.5.
1.5. This is 1.3, this is 1.5. Right, so
Okay.
that is why it is not proportional. What about 2? P is 4, Q is 4.5, PF is 8, and RF is 9.
Yes, they are proportional.
Yeah, both will be 8 upon 9.
Yes.
Then you have PQ is 1.28, right? PR is 2.56, P is 0.18, and PF is 0.36.
Yes, they are proportional
Why?
because the ratio of the full sides like PQ upon PR is 1 upon 2 and the half sides is still 1 upon 2. PE upon PF.
So see here you should not take ratio between PQ and PR,
So we
right? You
can
should
say
go by
that
BPT first.
yes.
Okay, what does BPT say? P upon EQ should be equal to PF upon FR. Right, do you know PE here? PE is 0.18.
Yes.
What is EQ? EQ you don't know.
We can find it, right?
Yeah,
It should be 1.1.
yeah, so it will be 1.1. Should be equal to PF, which is 0.36 upon
Yes. 2.2.
2.2. Right, now you can say they are equal. You can simplify this. So you'll again get 0.18 upon 1.1. Right, so you have to check for BPT, not similarity.
Yes.
Right, so when it is saying BPT, you should apply the formula for BPT only. Any doubt?
Yes. No, sir.
Okay. In figure 6.18, if LM is parallel to CB, LM is parallel to CB, so this means equal, but I am using this to represent parallel, or say, let me use this arrow sign. So LM is parallel to BC and LN is parallel to CD,
Yes.
right? Prove that AM upon AB is equal to AN upon ND. Sorry, AN upon AD, not ND.
Sir, but it's not a triangle, right? So can we apply BPT?
You have to find that triangle.
Or we can join B and D and eliminate the right hand side part of the C.
If you join this, okay, but where is that parallel? So you can no longer apply BPT.
Yes. So for the first one, we can take ABC and second one ADC.
Yeah. So you already have a triangle, right? ABC is already a triangle, right? So in this triangle, you have LM parallel to BC,
Yes.
right? So you can already write AM upon MB,
Should be equal to AL upon AC. LC.
AL upon LC, right? And then
Yes.
from the second triangle, what can you say?
AN upon ND.
AN upon ND is equal to
AL upon LC.
AL upon LC. So from both these equations, you can say
Yeah.
right. But what do you need to prove? AM upon AB, not MB.
Yeah. So we have to do the flipping thing.
Yeah, very good. So you have to flip this because you don't want this, you want this. So whatever you don't want, put it in the numerator. Right, so you'll write MB plus AM because we are adding 1 on both sides upon MB is equal to ND plus AN upon ND, right?
Yes.
So you'll get AM plus MB is AB. Sorry, we flipped that, right?
Yes.
So this will be AM, not MB, because we have flipped it, and then this will be AM, right?
Yeah. So AB upon AM.
Yeah. AB upon AM is equal to
AD upon AM.
yeah AD upon AN. Then you again, if you flip this, you'll get the same thing, right?
Yes.
In figure 6.19, DE is parallel to AC, right? And DF is parallel to AE, right? So this and this is parallel, this and this is parallel, right? You need to prove BF. So this is BF upon FE. So this upon this is equal to BE upon EC, is equal to this upon this.
Okay.
How to prove this? So first of all,
So
tell me which two triangles to take.
so we will have to take two sets, right? So DBF and ABA.
DBF. So when you take DBF, so there is no parallel side that you'll have to take into consideration, right?
So we have ABE.
Yeah, so this should be the triangle, right? So look at this side. We have to prove BF upon FE. So BF, FE. So this is the triangle, right?
Yes.
Another triangle, you have to take BE and EC. So BE and EC. So this is the triangle entire.
Yes.
Is this clear?
Yes.
So if you take triangle ABE, you know DF is parallel to AE. So from BPT you can say AD upon DB
Is equal to BF upon BF.
is because we started from here, right? So AD upon DB. So we'll again start from here. EF upon FB, right? Or EF upon BF. Or we could have written BD upon AD is equal to BF upon FE. Both would mean the same thing, right? And in this second triangle, you know ED is parallel to AC, right? So you can write AD upon DB should be equal to what?
So we the bigger triangle, right?
Yeah.
BE upon AC.
So we have
Yes.
taken AD,
Yeah.
right? So AD upon DB.
So CE upon EB.
Yeah. CE upon
EB.
CE upon EB. Right. So if you compare both these sides, AB and DB will get cancelled. So you'll get EF upon BF equals to CE upon EB.
Yes. So now we have to flip it.
Yeah. So BF upon EF is equal to
BE upon C.
B upon C. Right? Any doubt?
No, sir.
Yeah. So see, in this triangle, what we did, so just look at the parallel sides. So these two are parallel sides. So if you take either BD upon DA, you should take BE upon EC. Here I took AD upon DB, so I took CE upon EB, right? And not BE upon EC. Depends on the order. So if you are doing like this, BD upon DA is equal to BE upon EC. So it is always better to have a common point to start.
Yeah.
Okay.
Sir, but the order in which we write the side is not important, right?
No,
Like PE or EB.
no. So what I was trying to say is, if you write AD upon DB, so if you'll have some confusion in writing, say either I should write BE upon EC or CE upon EB. So that may create a confusion. So it is always better. So for example, we know that this side and this side are parallel,
Yes.
right? So look at this point which is opposite. B is the point.
Yeah.
So you can write BD upon DA, this is one side, and then you can write BE upon EC on the other side.
Yes.
So then you don't have any source of confusion. Okay?
Yes. But sir, like, uh, if we once prove that, once after all the proving, if we got something like FB upon EF equals EB upon EC, so
Sorry,
do we have
FB upon. Okay, you mean this one?
yeah anything like that?
Yeah.
So do we have to write one more step like BF upon FE equals BE upon EC and like add
Yeah,
it?
it's up to you. I mean, it is always better if you, I mean, write the exact wording what they have provided,
Okay.
right? Or try to choose wordings that matches what they say. Say they say BF upon FE, right? So I should have written BF upon FE here,
Okay.
right? And not FB upon EF. So it is always better to start from what they have given. But if you are not able to, then I mean, there's no issue. At the end, you can always flip,
Yeah.
right? Because they mean the same thing. Either you take FB or BF. They are the same line segment. Okay?
Yes.
Yeah. Question number 5, again, a similar question. Questions on BPT are very similar and easy. In figure 6.20, D is parallel to OQ. So you have DE is parallel to OQ. So whenever parallel lines are given, you know the triangle that you need to take. And DF is parallel to OR. You need to prove that EF is parallel to QR. So EF and QR are parallel. Right, I'll tell you how to find triangles. So maybe this will be helpful for other questions. So see, D is parallel to OQ. So DE is parallel to OQ. Right, so this gives you this triangle. Right?
PO.
Yeah. So one triangle is POQ. So if you apply BPT in POQ, you get, so again this line is parallel, so I'll start from this point. So P upon EQ is equal to PD upon DO, right?
Yeah.
Then it
Yes.
is given DF is parallel to OR. So what triangle to take?
POR.
Yeah, very good. So POR, right? So in triangle POR, again you'll take P as the point. So PD upon DO is equal to PF upon FR. So for both the cases we used BPT. So this is BPT, this is from BPT, right? Now if you compare both of these, what can you say?
P upon EQ equals PF upon FR.
Now look at the ratios. P upon EQ is equal to PF upon FR.
Yes. So EF should be equal to Q1,
Yeah,
parallel.
parallel to QR, right? From converse of BPT.
Yes.
Okay. In figure 6.21, A, B, and C are points on OP. So if you take this line OP, so A is a point on OP, right? B is a point on OQ, and C is a point on OR. Then you join all three of them,
Yes.
right? Such that AB and PQ are parallel, AC and PR are parallel. So So you just need to show BC is parallel to QR.
Okay.
Will you be able to do this question?
Yes.
Okay, this I'm leaving it as a homework. You can try to solve this question. Okay, again there is nothing in this question. What you just need to do is, so this triangle PA upon AO is, take this as the point. So OA upon PA is equal to OB upon BQ. In this triangle, you'll get OC upon CR is equal to OA upon PA. So from both this common term will get removed. So you'll get this is equal to this, right?
Okay.
So
Yes.
converse will apply. Okay,
Yes.
so try solving this. Now using theorem 6.1. What is theorem 6.1? So in exam you'll not be given using theorem 6.1. It will be given that using BPT or basic proportionality theorem. So when you are applying something or when you are writing something, don't write just BPT, you write basic proportionality theorem. Okay. Now using the basic proportionality theorem, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. What is this? This is the midpoint theorem, right?
Yeah.
So we are using the basic proportionality theorem to prove the midpoint theorem, right? Earlier we have used congruency to prove this midpoint theorem,
Yeah.
right? Now you should understand that midpoint theorem is a specific case of basic proportionality theorem. So say this is ABC, right? Let P be a point,
Yeah.
right, on this triangle, which is the midpoint of AB. It is already given. Prove that a line drawn through the midpoint of one side of triangle parallel to another side. So you have put a point P, which is the midpoint of AB, and then drawn a line parallel to BC.
Yes.
So you have to prove that, say this is Q. So it is given that AP is equal to PB
Yes.
and PQ is parallel to BC. These two things are given.
So AQ is equal to QC.
Yeah, you have to prove that AQ is equal to QC, right?
Okay. So we can just apply the BPT here.
Yeah. So since PQ is parallel to BC, you can say AP upon PB is equal to AQ upon QC.
Yes.
AP is equal to PB, so this ratio becomes 1. So you can say AQ is equal to QC. So when AQ is equal to QC, this means Q is the midpoint of AC, right?
So yes.
So which means Q bisects AC.
Yes.
Okay, any doubt?
Yes.
Using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. What is
So
6.2?
we have to do the same thing but converse.
Yeah, you should apply the converse of BPT,
Yes.
right? You know, so you have a triangle ABC, right? So P is the midpoint of AB and Q is the midpoint of AC. So if you join this line, you should prove that PQ is parallel to BC.
Yeah.
How can you do this?
So by the same approach of the last question, right?
Yeah, but last question you were given PQ is parallel to BC. Here you have to prove this.
So we know AP is equal to AB, BP.
Yeah, AP is equal to PB,
Yes.
and
AQ equals to CQ.
yeah, AQ is equal to QC.
Yes.
Then
So we can say that the ratios are same. That's why we can apply BPT.
yeah, so see, AP upon PB is equal to 1. This is also equal to AQ upon AC, AQ upon QC,
Yeah.
right? So AP upon PB is equal to AQ upon QC, right? Since the sides are proportional, which means the converse of BPT applies, and PQ must be parallel to BC,
Yes.
right? Is this clear?
Yes.
Then you have ABCD is a trapezium. So you have a trapezium in which AB is parallel to DC, okay? And
Okay.
its diagonals intersect each other at the point O. So this is one diagonal, this is another diagonal. So they intersect at point O, right?
Yes.
So you have to prove AO upon BO, right? So
Yes.
AO upon BO is equal to CO upon DO.
Okay. So I think it's given, right? Oh, no.
You have to prove this particular thing.
Yes. So we can first take triangle ABC.
Okay, let us take triangle ABC.
Yeah. So over there, so we cannot use BPT over here, right?
Yeah, we cannot
Because
use,
only
because we have
one
one thing
side
missing.
is divided. Yeah, only one side is divided into two parts.
So you cannot use BPT because, so see, if you take triangle ABC,
Yes.
right? If you take triangle ABC, you can get AO upon what you have, AO upon OC,
See.
right? So if you, I mean, this is just, they've just taken some terms to the right hand side. So you can get AO upon CO, right?
Yes.
Is this clear? So this is basically saying AO upon CO is equal to BO upon DO. This is
Yes.
equivalent, right?
Yes.
So AO upon CO you can get from here, AO CO.
Yes.
But how
So
do you get this? How can you apply
so
BPT when you don't have anything that is parallel?
yeah. So we can make a parallel.
Yeah, you can make a parallel line. So here you have to remember that until and unless you don't have a parallel line, you cannot apply BPT. So say draw a parallel line like this. Okay.
Yes.
So this is O, let this be P.
Okay.
Right, now what next?
So now we can take in triangle ABC, AP, AB
ABC.
is parallel, AB is parallel to OP.
Yeah,
So AO upon CO should be equal to BP upon CP.
BP upon CP. Yeah, fine.
Yes.
Then
And
what
if
is the other triangle you should take?
ADC, right?
ADC. If you take ADC, so you need DO and BO, right?
Yes.
You need DO and BO.
So we can take ABD.
ABD. So see, because you have drawn this parallel line,
Yeah.
right? So you should, so this side should be fixed so that, because you don't know this point, you don't know anything about this point, you have constructed it, right?
Yes.
So this side should always be in the other triangle as well,
Okay.
right? Is this clear what I am saying?
Yeah. So I think BCD.
Yeah, very good. So in BCD you can write BO upon DO,
Yes.
right, is
So
equal to
BP upon CP.
BP upon CP, right?
Yes.
Now you can cancel these two terms to get AO upon OC is equal to BO upon DO.
Yeah, and then we have to do some adjustments.
Yeah. Okay. Now 10 is the converse of 9.
Yes.
Right? Same question.
So
It,
sir, will the figure be the same?
yeah, it can. I mean, you can draw a random figure, but you have to prove that it is trapezium. So you can just take a trapezium, start with a trapezium, but you don't have to specify that it is a trapezium.
We can say quadrilateral
Yeah,
ABC.
let this be a quadrilateral. Right, so you are already given this, so you have to prove the converse, which means you have to prove that this AB is parallel to DC. Right, I'll leave this 10 and 7 as a homework. Sorry, not 7, 6.
Yes.
Try solving these two. If you have any issues, we'll discuss in the next class.